Section 3.2 Measures of Variation. In this, usually measure variations, there are three of them that we focus on. One is called the range, one is called the inner quartile range, and one called standard deviation, which is the most important, standard deviation. In this section, we just introduced two of them, the range and the standard deviation. What is the range? Range of the data, you take always the highest value. So here they talk about those players, who's the shortest, who's the tallest. So you always take to find the range of the data, you always take the maximum minus the minimum, or the highest minus lowest in this case. Highest value minus lowest, or the tallest minus shortest. So that's called the range. That's called the range. The next one is the standard deviation, or we call it sample standard deviation specifically. We use small s to abbreviate the sample standard deviation. So S is the sample standard deviation. What is standard deviation or sample standard deviation? It talks about the spread of the data. So this talks about spread of data. Or the variation. So what happened? The standard deviation tells us how large the data is spread. The larger the standard deviation, the more the spread, the more the variation. That's what standard deviation is. One more time. Standard deviation tells us how large the variation is for a given data. How large is it spreading? The larger the standard deviation, the larger the spread. Now, to calculate the standard deviation, we have two formulas. The first one is given by this one, the square root of the sum xi minus x bar square, all divided by n minus 1. And we are going to see how to calculate this for a specific example. Let's say I'm going to scroll up and take this example here. Say 67, 72, 76, 76, and 84. We have five values. We need to determine the sample standard deviation S. The way I do it, I use tables to organize my work. First thing, I find x bar, the mean from the previous section is xi over n. So we add the numbers up all the way to the end, and we got 2, 4, 5 of them. If you calculate it, you get 75. So now I'm going to use a table here. In the table, I'm going to list the x values that they give us: 67, 72, 76, 76, and 84. Here we put x bar, the mean, which is 75 for each one, for all these values. Now inside, if you look inside here, they said do xi minus x bar. So xi minus x bar. This is the xi. So we do 67 minus 75, which is negative 8. 72 minus 75, negative 3. 76 minus 75, 1. 76 minus 7, again 1. And 84 minus 75, which is 9. Then they said square it. So I'm going to square this, xi minus x bar square. So when I square negative 8 square, that's 64. You square the negative as well. Negative 3 squared is 9. 1 squared is 1. This is 1, and 81. Then they said sum them up. Add these up. Add these values that we got here. What's the sum? So we can add them all together and we get 156. Add the 64, 9, 1, 1, and 81. So then S, which is given by the square root of all this sum that we got 156 over n. N is 5 observations, 5 minus 1. That would be 156 over 4, and that divides evenly to 39. So that gives us, on the calculator, 6.2. Rounded, about 6.2. That's the standard deviation. Now, can we do it in a different way? Yes. The other method, which also there's more work to do in that, is this formula. So some people use this formula, some people use the other formula. So this formula, what we need to do is to sum up all the xi square, as we did in the previous section, and same thing, sum the entries and then square them. So we can apply this right now. So the entries, let me do it here. The entries that we had, 67, we had 72, 76, 76, and 84. So first thing we're gonna do is we can find the sum of xi all squares. This is basically you add them up all and then square the result. And what does that tell us? That gives me 375 all square. Let's keep it like that for now. For the other one, what we need to do is we need to take each entry and square it. 72 square, or each observation 84 square. When we calculate this, that gives us 28,281. Then we are ready to find S. Is the square root of the first one, 28,281, minus the sum square, I found it there, 375 square, over n, which is 5, then over n minus 1. If you put, first thing you do is this part, so keep this the same. We need to calculate what that is. That's 28,125 all over 4. Then you do this one, 156 over 4, 39, which is about 6.2. Same answer. What else we need to know about standard deviations? Let's look at this table has two different datas, data 1 and data 2. Look at the numbers. The numbers that you see here, 41, 44, all the way to 66. In the other one, you get 20, 37, and then all the way to 70. What's the difference between these two datas? Well, I see that data 2 is spread more. The numbers are spread more. You're going from 20 to 70. That's a range of 50. The other one is 41 to 66. That's a range of what? Subtract them. 66 minus 41. That's a range of 25. There's difference. The other one had a range of 50. Okay, so that's the difference. So now we expect, if we calculate the standard deviation for both of them, we expect data 2 standard deviation to be larger than the first data because the spread is more. And that's what we did here. We found the mean, 50 for each one of them. Notice they have the same mean, but the standard deviation is different. So data 2 has a bigger standard deviation because the spread is more. That's good to know. Now, if we look at the first data, back to the same table from above. So the mean we found, it was 50, data 1. So that's the mean. Now, if we add the standard deviation to the mean, so to 50, if you add this S, which is 50 plus 7.4, that's 57.4. That goes here. Add it again, you get 64.8. Add it again, you get 72.2. If we subtract it, if you do 50 minus S, 50 minus 7.4, we get 42.6. And that's what we got here. Subtract it again, subtract again. So notice what we did, that's the mean. We went, this one is called one standard deviation above the mean. One standard deviation above the mean. This one is 2 standard deviation above the mean. This one, 3 standard deviation above the mean. This is 1 standard deviation below the mean, 2 standard deviation below the mean, 3 standard deviation below the mean. And why did we go up all the way up to 3 or down to 3? Because most of the data, and we will learn that later on, most of the data, and I tell you exactly what it is, about 99.7% of the data will fall within 3 standard deviation of the mean. Within means 3 standard deviation above and 3 standard deviation below the mean. That's what within means. If you look at the next data, it had the same mean. You know, data 2 had same mean, but the standard deviation was bigger. So when you take 50 and add the 14.2 to it, that gives us 64 point something. Add it again and again, subtract it, subtract it, and that's what we get. Now notice at these two of them, they put the dots. We marked the dots. The first one was 41, so they marked it here. The next dot 44, it was marked down here. The next dot 45 right next to it, and so on and so forth. That's what these green dots are. The next one, same thing. They marked all these green dots. Notice many things here. The first thing, look at the spread of the data. This one has a larger spread than this, right? So it's wider. That's the first thing. Another thing, if you look at the data, all the data fell within 3 standard deviation for the first one. All of them. You don't see any values on this side or any values on that side, any of the green dots. Same thing here. You don't see any values here or any values there. Do you see that? So that's what the book calls it, 3 standard deviation rule. Almost all the observations. The reason I said almost because about 99.7% will fall there. In any data set lie within 3 standard deviation to either side of the mean. To either side of the mean. That's what standard deviation is about. You need to learn how to calculate standard deviations and how you can interpret the results here on the graph. Now, is there a way to find the standard deviation on the calculator, on the graphing calculator, let's say? Yes, always you can Google for whatever calculator you have. You can Google, let's say you have TI-84 plus. You can Google for that, how to find or calculate the standard deviation on the TI-84 plus, and it will show you instructions how to do that. So if I want to run some calculations on my calculator right now, just to tell you, I can write the steps down. What you need to do is you need to go to stat. This is for TI-84 plus. You go to stat first and hit the enter key. This will take you to lists. So under L1 you enter the numbers 67, hit the enter key, then 72, enter, all the way until you enter all the data. So that's what I'm gonna do now. 67, 72, 76, 76, and 84. So I entered all the data. Then we go back to stat, click on stat, and then go to calc and hit the enter key. And then you can scroll down to calculate using the arrows, calculate, and hit the enter key. So what the calculator is going to give us is going to give you the first value, x bar, that's the mean. It's going to give you the sum of x 375. That's the sum of all the values. It's going to give you the sum of x squared, the ones that we did calculate by hand. And it's going to give you sx, which is 6.244 something something. You know, the one I give you was estimated, so I give you this. And it will give you this simple here. This simple is 5.58. This is the sample standard deviation. And that's what we are looking for. This is the population standard deviation, which you don't need for now. Okay. Now if you scroll down on the calculator, it gives you N5, and it gives you other stuff that we're going to be using later on in section 3.4. So that's how you calculate on the graph, on the graphing calculator, or using the graphing calculator.